There are various applications of first derivative. In this video, let us see monotonicity of functions. In an interval, if a function is only increasing or decreasing, function is said to be monotonic. Now, y is a function of x. Whenever a is lesser than b, f of a is lesser than b, then it is called strictly increasing. Let us see one example. Y is a function of x, so let it be x. So this is the graph. Y is equal to x. When x is 1, y is also 1. When x is 2, y is 2. So this is a strictly increasing function. Here you can let a be 1 and b be 3. So a is lesser than b. So 1 is lesser than 3. When x is 1, y is also 1. So f of 1 is 1. F of 3 is 3. So when a is lesser than b, f of a is lesser than f of b. So same order. So this is strictly increasing. Now you see the first derivative, dy by dx, or f dash x is equal to 1. Differential coefficient dy by dx is 1. So you can see it's a positive value. It's a positive. So first derivative is positive. So first derivative is positive. This is a strictly increasing function. But if it is strictly increasing, first derivative need not be positive. That I will give another example later. Now another function, y is equal to minus x. Y is equal to minus x. Then this is the graph. Now when x is 1, y is minus 1. When x is 1, y is minus 1. When x is 2, y is minus 2. When x is 1, y is minus 1. When x is 2, y is minus 2. Now we can see 1 is lesser than 2. 1 is lesser than 2. When 1, it is a minus 1. When x is 2, y is minus 2. But you can see minus 2 is lesser than minus 1. So it is strictly decreasing. Now first derivative y dy by dx is equal to minus 1. So first derivative is negative. If first derivative is negative, it is strictly decreasing. Let us see another example. Y is a function of x. That is x square. Y is equal to x square. So this is the graph. When x is 1, y is 1. When x is 2, 2 square 4. When x is increasing, y is also increasing. So here graph is rising from 0 to infinity. Minus infinity to 0, the graph is falling. It's a decreasing. Now let us see. For a strictly increasing function, whenever a is lesser than b, f of a is also lesser than f of b. Strictly increasing. If it is increasing, here there can be equal sign. f of a is lesser than or equal to f of b. Now here you can see 1 is lesser than 2. F of 1 is lesser than f of 2 because f of 1 is 1, f of 2 is 4. Because when you put x2, 2 square is 4, f of 2 is 4. So you can see the same order. So here function is strictly increasing. This side it is decreasing, minus infinity to 0. So minus 1, minus 2. So minus 1 is greater than minus 2. F of minus 1, for this x you put to minus 1 square is 1. F of minus 1 is 1. F of minus 2, for this x if you put to minus 2 square is 4. So you can see order is not preserved. So here minus 2 is lesser than minus 1, but f of minus 2 is greater than f of minus 1. So here in the same order, but here order is not preserved. From minus infinity to 0, function is decreasing. 0 to infinity it is increasing. Now let us see the first derivative. So this is one of the applications of first derivative. You find out the first derivative, f dash x. Derivative of x square is 2x. So now take a value here 2 or any value. Now this positive, for this x if you put to 2 into 2, 4 is a positive value. So first derivative is positive. First derivative is positive, function is increasing. Then if you take a value here, negative value, for this x you put a negative value, so first derivative will be negative. So here first derivative is negative. From minus infinity to 0, first derivative is negative. So first derivative is negative, function is decreasing, and first derivative is positive, function is increasing. But function is increasing, first derivative need not be positive. If first derivative is positive, function is increasing, but function is increasing, first derivative need not be positive. That I will give another example. Here is another example. Y is equal to x cube. So this is the graph. So this is strictly increasing from minus infinity to plus infinity. You can see the graph is rising. When x is 1, y is 1 because 1 cube is 1. When x is 2, 2 cube is 8. So 2 is greater than 1, 8 is greater than 1. So to show that it is strictly increasing, it is enough if you can show whenever a is greater than b, f of a is greater than f of b. F of a is a cube, f of b is b cube. So let us find a cube minus b cube. A cube minus, whether it can be positive or negative. A cube minus b cube can be written as a minus b, a square plus ab plus b square. Now this can be written like this, 1 by 2 outside, then 2 multiplied inside. Now this can be written as a plus b all square, because a plus b all square is a square plus 2ab plus b square, then here one a square, then b square. So here inside the bracket you can see all the terms are squared. So it cannot be negative, and this cannot be negative because we assumed a is greater than b. It can be 0 when a is equal to b, but that is a contradiction. We have assumed a is greater than b, so it is positive. That means a cube minus b cube is positive, that is greater than 0. That means a cube is greater than b cube. If you take to the other side, that means f of a is greater than f of b. So this function is strictly increasing. Now you find the first derivative, f dash x. Derivative of x cube is 3x square. But when x is 0, first derivative is 0. So it is strictly increasing, but first derivative is not positive. When x is 0, it is 0. First derivative is not positive. From this is clear, if first derivative is positive, strictly increasing, but strictly increasing, first derivative need not be positive. Here it is not positive, it is 0. Thank you for watching.